On the front of your blue packet, there's the power series you have to have memorized, and you should. You should have E's memorized, correct? On the front of your notes, 1 plus x squared over 2. That needs to be in your memory, and you need to be able to, given the same center, you need to be able to manipulate it. On your quiz, I gave you one that I shifted the center, and some of you neglected to notice that, and you modified, no, you were fine, and you modified the existing one. You have to actually create it from the ground up when I switch the center. What do I mean by from the ground up? The whole thing, the f of c plus f prime of c times blah, 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 all the derivative way. So watch out for that. And then we have sines, which is an odd function, so it goes x to the first minus x cubed over 3 factorial, right? Plus x to the fifth, blah. And then we have the cosines, which is the even function, 1 minus x, right? And then there's a new one in town from your notes, and it's on the front of your packet. The new one in town from your notes that you should memorize because it's not used as much, but this, guys, is such a simple expansion. What is it? 1 plus x squared plus x. Yeah, this one's super nice. We call this in geometric form because it's in the form a over 1 minus r, which is the sum of a geometric series that starts at a and has a common ratio of r. Makes sense, right? Just keep multiplying by x. Remember, we use this in place of this, but its domain is only where the two converge. So if I was using this, right, for this function, you can even see that this guy's got an asymptote where it has an asymptote at 1, right, a center of 0. So I even can tell that I can be within 1 of 0. This would be my interval of convergence, which means in here, these are identical. Outside of there, whoops, outside of there, they're not. All right, so if we can get it into geometric form, they're really easy to expand. So let's go take a look at this guy. This is what's called a rational expression. It was the first year I taught BC, they came back and it was kind of the potato of last year where you guys came in, you're like, oh, what was up with the potato? They were like, what was up with the rational function? What's that? And I had always called it geometric form, and on College Board they said write a rational expression. And that totally screwed them up, just the change in language. So it was my fault. So I'm going to drill that home, that this is in geometric form, but it's a rational expression. Think fractional. If I can identify the a and the r once it's in that form, I don't need to do it from the ground up. So this one, it's very clear, right? This f of x, which is 1 over 1 minus x, has a power series expansion that goes with it. It starts at a, and then what will I continually multiply by? X squared is my common ratio. So this is the r. So I don't need to build it from the ground up. I just say, well, I'm going to multiply 1 by r, right? And then by r again, and then by r again. And I've taken care of my first 4 non-zero terms, right? Plus dot, dot, dot. That's easy, correct? And after I do the dot, 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 what does my general term look like? It's got the even powers, x to the 2n. There's no alternator attached. I would just need to indicate that I'm starting at what? 0, right? And I'm done. That's good. Now, if I were to go graph, just so you understand what would happen, if I were to go graph this, right? And then go graph this guy. Because this is geometric, I don't need to do a ratio test on this. For geometric, the absolute value of your common ratio has to be less than 1, right? What does that mean? It means then my x would have to be less than 1 and greater than -1, so I can immediately see that. So we'll go graph a different one later, but if I were to graph this one, and then I were to graph this as far out as I wanted to, that when I hit graph for both of them, they will collide perfectly between -1 and 1, and then outside of there it'll be off. Does that whole concept make sense? And we'll go graph one in a little bit, but that's what it means with this. Just make sure you understand what that radius of convergence is. Actually, let's go do it. Go take out your calculator. Might as well. It's cool to see it. So take out your calculator. I'm going to just use the one on my desk, not my online one, because I don't have it. Might as well. It's once you see them, I think, as we go along, it's easier to understand what you're doing. So we had 1 over x squared. I'm just going to hit graph with that one to plop it up there. So when I hit graph, kind of interesting here, it's got asymptotes at 1 and at -1. And then I've got this going in between. And then I've got that in blue. So this is the original function that they gave me right here when I graph it. What I've just determined is between the asymptotes, my polynomial that I enter will hug it perfectly, and better and better and better the more terms I enter. So take out your calculator and go to y2, and let's enter it out to, I think I'll go out to x to the 8th. So I'm going to enter 1 plus x squared plus x to the 4th plus, this is boring, x to the 6th. I think I'll go out to x to the 8th. I'll hit graph, and I will see an 8th degree polynomial try to hug that curve. It'll be great, right? Does anyone have the color-coded graph? I like that. Actually, this is looking, mine, because they're both in black, does anyone have the color screen? It's hard for me to see where it diverges. All right, thank you, Eva. And she's zoomed in. So what she's got is a little issue coming in after that asymptote. Then it seems to hit it really nice. It's a little bit more flat, and then it goes like this. It's horrible outside the interval of convergence, though. Wouldn't you agree? Like if I was using my polynomial to estimate what happens right here, the actual value is right there, and my polynomial will give me that. Like it wouldn't even be close. That's our next topic, by the way, is to figure out what the error is. It's called Lagrange error bound. So that's up next. All right, are we good? How could I make hers hug it more? Add more terms, just so we've got it. All right. By the way, knowing where the asymptotes are for the ones in geometric form can help you really have a good intuition about what'll happen. Let's go look at number 6 then. So on number 6, I've got an issue because I need to have it be a over 1 minus r. So I feel like I'm having a little bit of an issue because I don't have the plus and I don't have the 1. Well, that's the beauty of math. You can create whatever you want to create as long as you don't break any rules. So I will, by the way, I could do this from the grassroots. This should be centered at 0. Sorry, that's important. I could just start this and say this, g of x equals 1 over 4 plus x, and g of 0 is 1/4, and I'd write a 1/4 plus, right? I could do the Taylor expansion. I could do g prime of x. What would it be? -1 over 4 plus x, quantity squared. At 0, what would that be? Minus 1/4, right? I could do that. But, and if you get stuck, you go ahead and do it. But the goal of today's lesson is to say, with some of these rational expressions, if you can put them into geometric form, it takes a lot of the work out of it. So what I don't like about this guy is the 4. So what I'll do is what's totally legal. If I want to get rid of the 4, totally legal for me to take 1/4 of it. But if I'm going to take 1/4 of the denominator and I want to keep it still equal, I'd have to do 1/4 on the numerator as well. Technically, I've multiplied it by 1. That's always legal in math, and it's done a lot, right? 1 disguised as something a little funky. So when I now write it, I'd have 1/4 over 1 plus what? X over 4. Now this is really close. Now what's the only thing keeping it from being the sum of a geometric series? The plus, right? So you can even just think, oh, r would just be negative, but if you're ever asked to write it, you should really write minus and then do the negative. So when you have your key players, the a and the r, then you can just expand it by continually multiplying by the common ratio. So what my expansion would look like, right? So now that I have this in geometric form, I can now say that it starts at 1/4. Then what? That's my start. Then what? Yes, I'll multiply it by, and I would get a minus x over 16 However, you might want to write it as 4 squared, maybe, right? What would the next one be? Plus x squared over, I'm going to write it as 4 cubed. I said I'd leave the arithmetic off your paper when you have to write a general term. It helps. So what I do is call that a 4 squared just to keep your life easy. Did it say the first 3 or the first 4 terms? It's usually the first 4, right? So then I'll continually multiply by this common ratio and write minus x cubed over 4 to the 4th plus dot, 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 right? Now, Megan, I'll let you pick what you want to use as your n, and I will adjust my indices accordingly. Do you want to start at 0 or at 1? If she's going to start at 0, I'll label these, and I will create it thusly, right? She would then have x to the n. Agreed? Over what? Yep, I'll get that in there in just a second. Over what? Actually, I was going to leave it off on purpose, but 4 to the n plus 1. Awesome. It also needs a what? Alternator. You could attach it with the 4, but usually you have the alternator like on its own. Now, when I'm doing the alternator, I have to decide what I want. Do I want an n plus 1 or an n? Run a check. What do you think? And I'll do it, right? So here it is, dot, dot, dot. If I had to write it as its series, I'd say n goes from, she started me at 0. Now, what if she had told me to start at 1? How would it change things? If she had said, no, I just asked her, and actually last hour I think they did say to start it at 1. How would it change my general term? It'd be x to the n minus 1 over 4 to the n, so it's really no more ugly. And then what would my alternator have attached to it? Because if I'm going to start that at 1 and I need it to go, yeah, I'd do an n plus 1 on there then. But this is good, so I'm done. Did it say to find the interval of convergence? All right, so again, because it's geometric, all you need to do is make sure the absolute value of your common ratio is less than 1. Then detach the constant from it, right? So I would have a 1/4. When I take the absolute value of the negative 1/4, absolute value of x is less than 1. So I get the absolute value of x is less than 4. Really what this means is I can be 4 units. This gives you the radius. I can be 4 units from the center. And what was my center? 0. So a lot of kids will set up an inequality right here, which is fine. You go back to like algebra 1 and solve a absolute value inequality, but really this just means 4 units from the center 0. Do I have to consider beefy, wimpy, wimpy, beefy? That's the other value of this. If you can write it as geometric, you're 100% convinced they're both wimpy. Had I done this and continued with it this way, yes. I don't think so. We'll look at some scoring rubrics, but I think it would be assumed that you're using geometric for this. So if it said, I'm going to be honest, most of the ones where you have to do interval of convergence on the AP test are the ratio test. They aren't geometric. There have been a couple though. I'm going to show you one once we get there. So I need to turn the page. Do you guys see my page turner? Oh, it's hiding right here. All right. So now we'll even bump it up a little bit more. I've got a center of 1. Well, I need to introduce my center because it needs to be in the common ratio. Now I'm going to go over here and have you write something down. Go ahead. I want you to see the tie-in between what you were doing and what we're now doing. Right, f of x equals 1 over x. I am going to generate the power series with Taylor's rule. All right? Taylor's rule says that you do f of the center, which would be f of 1, which is 1. And again, I'm repeating it again, just to make sure. What does Taylor's rule make you do next? Take the derivative. So we'll do f prime of x, which would be negative 1 over x squared. F prime of 1 would be negative 1. I'm going to crank this out to the 4th derivative. I know we hate Taylor's rule, but it is what it is. My f double prime of x, that's really negative x to the negative 2, would be 2 over x cubed, right? Watch my arithmetic, but I'm good, I think. So my f double prime at 1 will equal 2. Am I going too fast, Kovac? I'm good. My f triple, well, this is 2x to the negative. Now, notice the alternator coming in because of this negative positive stuff going on here. My f triple prime of x would be negative 6 over x to the 4th. Now watch what's being generated. I'm glad I chose this one to expand the long way because I want you to see something. And then the next one would be, there's a pattern here now. What am I getting in my numerators? Watch when I do it again, because now I'm going to have 1, and then it's times 2, and then times 3, and now it's going to be negative 6. It's going to go times 4, right? Actually, boom. It's going to be 24. What are these in the numerators? Those are factorials. So they're being created by this repetitive derivative stuff. So watch when I write it out, because it said the first 4. I'm going to pretend LaRue never said anything about geometric series expansions, and we are not doing today's lesson, and this was on worksheet 5A. I would have said that my function 1 over x will equal, and again, this is when it's centered at 1, f of 1, right? Then, and technically, that's done, plus f double prime at 1, which would be negative 1, times x minus c to the first over 1 factorial, right? Next step, plus f double prime at c, x minus 1 to the second over what? 2 factorial. Then it'd be minus f triple prime, x minus 1 to the third, over 3 factorial. And I do want to do one more, even though it said the first 4. I'm going to do another one for you. My next one would be plus f to the 4th, x minus 1 to the 4th, over 4 factorial, plus dot, dot, dot for now. All right, what will I now do? Cancel the factorials. Exactly, this and this are gone, this and this are gone, this and this are gone. I'm left with 1 minus x minus 1 plus x minus 1 squared. Do you see what's going on here? There is definitely a common ratio. You can see it, right? What am I multiplying by to get from here to here? X minus 1, negative, right? And you can even just go backwards and I can see that. Watch that be created up here. So let's go up here and do it the new way. My problem, you'll notice my center has been introduced into my common ratio. Agreed? I've now introduced not just x, there's an x minus 1 in my common ratio. What that means is I need to write this as a over 1 minus r, and I need to make sure that my center gets in my common ratio. That means I need to introduce x minus 1 down there. Well, how in the world do I do that? Well, let's go give it a whirl. Whoops, sorry. This should equal 1 over, and I want this to be a 1. I can create a 1. It's perfectly legal for me to put a 1 there. Agreed? There. Yeah, it just took a little. Are these equal? Yes. Agreed? Right? The left is equal to the right. I've got 1 plus a common ratio. Well, shoot. Well, how do I adjust that? Yeah, it's really, my r is actually a negative. If you want to write it correctly, it'd look like this. 1 minus a negative x minus 1. And these are always checkable. Whatever you did, undo it and make sure you get the original back. For example, this and this would make a positive x, right? The 3 of them would make a minus 1, and I have 1 minus it. So that's 1 over x. My a is 1, so now I can start to create it. Here's my function. 1 over x is actually, it starts at 1. Here's my common ratio. So I'd multiply by negative x minus 1, and then I do it again, and then I do it again, right? And it says first 3, blah, blah, blah. Isn't it exactly the same thing as my Taylor expansion? Agreed? And it should be, right? They're the same polynomial expressions. Now, this one, it's a little clearer what my interval of convergence is. Watch, the absolute value of my common ratio has to be less than what? Isn't that nice? Like compared to doing the ratio test, that's pretty nice. The negative gets killed off with the absolute value. So I actually have this. And now I'm going to pause for a second. I want you to really understand what this is. When it's written in x minus c, you can, because sometimes College Board will go like this, absolute value of x minus 4 less than 7. And they'll start asking you questions. What's the radius of convergence on that red expression? 7. What's its center? 4. It means you can be within 7 units from 4. This means I can be within 1 unit from what? 1. And I know you know how to solve it like this, but if you're ever asked to think about it, it really means I'm between 2 and what? 0. Now, and I know they're both wimpy, and again, why are they both wimpy? It's geometric, they always are. Now, if you really, really get it, I knew that was going to be my interval of convergence the minute I looked at this. Because where's that guy's asymptote? 0. And its center is at 1, correct? So I know I need to have a wimpy at 0. So I'm trying to make it so you can see it. I know I need a wimpy at 0 because there's an asymptote. I know I have a center at 1, so I can only go 1 in the other direction of the center. Does that make sense? Like it's super, yeah, like you can outsmart it if you really get it. The minute it asks me for interval of convergence, I'm looking at this going, you're telling me, here's what it's telling me. I'm centered at 1. Right? I have an asymptote here, and you can only go the same distance. So I knew I was going to get 0 to 2. How did I know what the graph looked like over there? It's a parent function, right? Looks like that. All right, what do you think? So this is just a new way to do an old process that makes it so much easier to understand. Again, this is the little bit more high powered than need be. So I'll put a little bit of a star on there. You will not see one probably like this on my test or the AP test, but it's good stuff. If you were taking it in college, you would see one at this level. All right, so it says find a power series for this. The minute I see the fraction, I think maybe I would try to go geometric. But if I couldn't, and it didn't tell me I had to, I could do Taylor's rule. It'd make me puke in my mouth a little bit, though. Why? I'm going to have negative exponents with the chain rule every time. But if I was really careful and was watching what I was doing, I could create it from scratch. But that's not my point today. I want to be able to write my function as a over 1 minus r so that I can put the a down and just keep multiplying by the r. This is my goal. Okay, so it's got several issues and we'll deal with them. First of all, I want you to center it at 2. Everybody look, I'm going to change this to a 2 just to even make it a little more rigorous. So we're going to center this at 2. I'm going to pause and talk super slow. Where is the asymptote? Okay. Where's the center? Okay. So really, this is what I know. My interval of convergence is 1/2 the asymptote. I just can't converge at an asymptote. I know the center's at 2. How far is it from the asymptote to 2? Yes, 1.5 or 3/2. So guess where the end of my interval of convergence will be? 7/2 or 3.5. Watch it fall out. And just me understanding it would never be presented that way in a text, right? They would never say that. But the whole process that we go through is going to give us that identically. So let's go up here and take a look. I've got multiple issues going on with it. First of all, I know my common ratio needs to have x minus 2's in it. It has to. It's not centered at the origin. So if I were to do this with Taylor's rule, I'd have all these x minus 2 squareds and x minus 2 cubes. So I will introduce that right now. Why? Because I need it and I can. I have now just disrupted, though, the balance of the equation. This is similar to completing this square. But it's don't be icky about completing a square because it's really just whatever you do in these parentheses, which I technically subtracted 4. I better make sure I counteract. What do I mean by that? Yes, I'm going to need to put a plus 4 down here. Now watch. Take a look at my denominator. I'll do it in blue. I have 2x minus 4, right? Minus 1, which is negative 5, then plus 4. I still have kept this totally equal to that, right? So let's go rewrite it. This would be 15 over. I've got this stuff. What's that? 3. And I'll put it out front. Why do you think I'll put the 3 out front? There's a reason for it. What am I trying to create? A over 1 minus r. What do I know needs to be in my r? The center. So addition's commutative. It's totally legal for me to swap them. It's got 2 issues. What are they? I don't have a 1. I'll combat that the way I told you. There's several ways people could teach to do that. I think the easiest way is just to tell you guys to take and multiply this by 1/3. But then if you're going to, what else do you need to do? Do the top by 1/3. This is very high powered stuff. You guys are focused, which is good. On the top, I now have a 5. On the bottom, I have a 1 plus a 2/3 x minus 2. They are identical. My original and this one, I'm just changing the format it's in. That's almost in geometric form. What does it need? It needs to be a minus. So really, what's my common ratio? Negative 2/3. Yeah, but if you were asked to write it technically in geometric form, I don't know that you would ever be asked to, but just so you understand, it'd be 1 minus a negative 2/3 x minus 2. That is now in geometric form. What does that allow me to do? It allows me to crank out my power series. I know where it starts, so let's do that. My power series for, what was the original function even? 15 over 2x minus 1 will equal, where does mine start? 5. Okay, then what? I will continually multiply by negative 2/3 x minus 2. So when I multiply this by negative 2/3, and again, I won't make it negative 10, I would just write it as 5 times 2/3 times x minus 2. I am multiplying this by the previous term, right? It was a 5, and I'm multiplying it by a negative 2/3 x minus 2. Write what the next term would be. Multiply it by a negative 2/3 x minus 2. And you should have a what? Plus 5 times what? 2/3 squared x minus 2 squared. Let's do one more. Again, you multiply the previous term by the common ratio. So that you could factor the 5 out, I suppose, but you could put it out front of your ESUM, but whatever. I'd have minus 5, 2/3 to the 4th. Oh, third, right? 2/3 to the 3rd. All right, I want you to go write the general term for that and write it in series notation. Go write the general term and series notation. And then we're going to stop and go into your worksheet 7A for a little bit, or 6A, sorry. It is nice if you detach that alternator from the constant, but I technically have to mark it right if you write like negative 5 to the whatever. But usually you see them with the alternator. All right, Billy, go ahead and tell me what you got. Negative 1. He's choosing to the n. Times 5. 2/3 to the n. All right, x minus 2 to the n. All right, and if I were to write that, that's the nth term. If I were to write it as a sum, I would start at 0 for yours. What did I say to do if this is a test? Hop in midstream and check it. Did any of you do that on your quiz? Because your quizzes went really well, and most of your general terms were right. So I would say hop in. If you're going to start at 0, go 0, 1, 2, 3. Hop in midstream, plug a 3 in, and make sure your last hour when I asked somebody for this one, they had a -1 to the n plus 1. And what happened when we checked it? The alternator was off, so all we did was subtract it. We erased it. It was fine. It's just a quick check. So when I put in a 3, I'll have -1 to the third. The alternator's good. 5 will stay. 2/3 to the third, and that one's golden. What would I have gotten if I'd ran through the derivatives and done Taylor's rule? That. Now let's talk about the interval of convergence. Because it's geometric, the absolute value of my common ratio, which was -2/3 times x minus 2, right? Was that my common ratio? Has to be less than 1 for a geometric series. If we can go geometric, we don't need to go ratio test. The -2/3 pops out as a +2/3. All right, are you ready? Now what? Now what? Multiply by the reciprocal or divide by 2/3, and I have the this is in the form where if College Board gives you this form and asks you what's the center, 2, what's the radius? 3/2. Now this is confirming my original where the asymptote was, right? You see, when I started this problem, I said, I know I have to have a left wimpy bound at 1/2 because I could see the asymptote there. And I knew my center was at 2. And that's what this is saying. You need to be within 1.5 units of 2. I know most of you solve it like this, and that's totally fine, and I've said it a lot. But be careful you understand what you're doing and not just getting an answer. You need to be within 1.5 units of 2. Where does that put you? Kruger, you said 7/2, right? Or 3.5. I like 7/2. And shouldn't be a shocker over here that I'm going to get what on this side? The asymptote. What do you think? Does it make sense? So you should really write it as 1/2 to 7/2. All right, at the bottom of one of your pages, I think it was back by example 5, and I don't have, it's an add to the notes after the first year I wrote the notes. I went and typed something in, and I just opened an old copy of the notes. I think on the bottom of one of the pages I have, yeah, I think it's on the bottom of this one. Here's what I wrote, because this is what, it screwed them up. I'm going to steal this. In example 5, it says, note, if given the power series expansion, so they actually had done a part A, and then in part B, it told them to take the derivative, and they had f prime of x, and it equaled something similar. I don't want to give you the exact one because it's going to be one that you practice next week, so I tweaked it, but this was, so they had done a f, and then it said write a polynomial for f prime, and they just power ruled it. You could probably see what f would have been the integral of this, whatever. It said write a rational expression for f prime. And they all came back and said, what was I supposed to do for that? What are you supposed to do for that? It's geometric form's other name. A rational expression means as a fraction. It means you need to identify A. Hello, here you are. It means you need to identify the common ratio. Just divide 1 by its previous and make sure you've got it rock solid. So what happens when you hop in midstream and divide this by this? What's my common ratio? -4x, or you can multiply. Most people, sometimes when they're trying to figure out what did I multiply, I'll say go backwards. What is it when you divide them? This is a -4, make sure it holds, multiply by -4x, -4, I'm totally confident my r is -4x. So when it says write a rational expression for it, my derivative would have been a over what? 1 plus 4x. That's all College Board was looking for. And the kids were like, I had like 2 who said, that was just putting it at a over 1. I'm like, yes. But it was my fault because I'd never used that language. So it's just, you learn when you teach, right? But so watch out for that. All right, take out your, I'm going to stop these.